Hello, my name is Maggie, and I'm a junior at West Virginia University studying electrical engineering. And today I'm going to be walking you through how to solve a source-free parallel second-order circuit. This basically is just combining principles from differential equations and circuit analysis. So the problem states to find V of t for all time greater than 0. We're given the initial voltage of 5 volts, the initial current of 0 amps, inductance of 1 Henry, capacitance of 10 millifarads, and the resistance of 1.923 ohms. So the first thing you want to do when solving any circuit like this one is to solve for alpha and omega naught. So for a parallel circuit, it's alpha is 1 over 2 RC, which we get 26, just plugging those numbers in. Omega naught is 1 over the square root of L times C. Plugging those numbers in, we get 10. This is very useful in order to determine whether the circuit is overdamped, underdamped, or critically damped. Why is that? It's because our initial V of t equations are different for all three of those circuits. So in this case, the circuit's overdamped since alpha is greater than omega naught. So we have the equation V of t equals a1 e to the s1t plus a2 e to the s2t. Since we have those alpha and omega naught values, the next step is to solve for s1 and 2. So that equation is negative alpha plus or minus, so that plus or minus is going to give us two values, the square root of alpha squared minus omega naught squared. Doing so, we get s1 is negative 2 and s2 is negative 50. Plug that back into the V of t equation, and then we need to solve for those coefficients, a1 plus a2, which is done by using the initial condition of 5 volts, so V of 0 is equal to V naught, which is equal to 5, and then we're plugging 0 in for t. So since t is 0, e to the 0 is 1, we get 5 equals a1 plus a2. Now, remember that because we need to solve for the derivative next. So we have a given derivative equation when the derivative is equal to 0, and that is negative 1 over RC times V naught plus R I naught. Plugging those numbers in, we get negative 260. We take the derivative of the V of t equation, set that equal to that negative 260, and we plug in 0 for t. So since e to the 0 is 1, we get negative 260 equals negative 2a1 minus 50a2. The negative 2 and negative 50 are coming out front as it's just a simple e to the t derivative. That coefficient from the exponent is brought out front. And then we have our 5 equals a1 plus a2. I personally like to solve for one variable and plug it into the equation of the next. We get our a1 of negative 0.2083 and a2 of 5.2083, and then we plug it into the initial equation, and that's how you solve a circuit.